Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 20, Cylinder, Cone and Sphere. We'll be discussing how to find the curved surface area, total surface area and the volumes of cones, spheres and hemisphere. We'll understand these with examples and solve many questions from exercise 20B and exercise 20C. Are you ready with your pen and papers? We'll solve together. First, let us understand what cones are. Here we have a few examples which we are all familiar with. Ice cream cone, then a cap. This is also in the form of a cone. Again, here we have another thing which is in the form of a cone. We are all familiar with cones. So, how much ice cream can be filled inside this ice cream cone? You want to find, right? So, by studying how to find the volume of a cone, you will understand what is the capacity of this cone. Now, if you want to paint this cap, how much amount of paint you will require? Or if you want to cover it with a paper, what is the area of paper that we need to cover this cap? Can be determined after you study the curved surface area of a cone. Okay. Now, here we have the definition. The solid obtained by revolving a right angle triangle about one of its sides other than hypotenuse is called a cone or a right circular cone. Did you understand? Here I have taken a right triangle. So this is my right triangle. A right triangle has a base, height or altitude and hypotenuse. Now you have to revolve it either along the base or along the height. Then you will be getting a right circular cone. Let's see how. So here I am holding a pen and I am revolving it along the height. Okay. I am revolving it along the height. So when you observe, you can see that when I revolve in this way, I am getting a cone. So this forms a conical shape. Clear? You have a right triangle. A right triangle has base, altitude and hypotenuse. So the revolution should either be along the base or along the altitude. When the revolution is along the altitude, you will be getting a cone of this form. Okay. So here we are holding the altitude and rotating it. Now what about the base? This base will become radius. Okay. Base will become the radius. Just observe here. I am holding this cone. This is my right triangle. This right triangle, here we have the height, and when I am rotating this pen edge is the center and this length is the radius of the cone which is formed. Base of cone that is formed. Clear? So the base becomes the radius. Okay. If now I am rotating along this direction, that is along the base, again I will be getting a cone which will be like this. Okay. This is how the rotation will be. Then the altitude will be the radius. Okay. Here this distance will be the radius. Clear? So for a cone, so this is my cone. A cone will be having radius and height. There is one more thing we have to study which is called slant height. Slant height is represented using the letter, small letter L. Radius R, height H and slant height L. Slant height is nothing but we have a slanting height here. Yes, that is when you consider this right triangle. In this right triangle, the hypotenuse of the right triangle is the slant height of cone. Okay, how to find the hypotenuse of right triangle? We have studied Pythagoras theorem, right? So using the Pythagoras theorem, we'll be having hypotenuse square is equal to base square plus height square. Okay. Here in place of hypotenuse, we have slant height which is represented using the letter L. L square will be equal to, base is the radius, R square plus height square. L square is equal to R square plus H square. If in the question radius and height of cone are given, we can find the slant height. Now let us see where do we need slant height. How to find the curved surface area of a cone. We have a cone. This is radius, this is height, and this is slant height. So curved surface area is this part, okay, not including the base. The cone without including the base, we get the curved surface area. That is the area of this part of the cap. To find curved surface area, we have a formula, that is curved surface area of cone is equal to pi r L. This is the formula to find curved surface area of cone. Pi r radius and slant height L. Remember, it is not the height we are using here. We are using the slant height to find the curved surface area. Next is the total surface area. Total surface area. So total surface area is determined. Here for total surface area, you will be having the curved surface and base. For cylinder, we have done this. In case of cylinder, we had curved surface, base and top. Here in this case, we don't have a top. In case of a cone, for cylinder, it was like when you pile up many circles together, you will be getting a cylinder. Okay, they are circles of equal radius. When it comes to cone, at the base you will have a big circle, and when you go to the top, the radius of circles goes on decreasing. Okay, so circles whose radius will go on decreasing, and finally the end will be pointed. Then you will be getting a cone. Okay, so in case of a cone, the radius is decreasing. You have only the base and don't have the top. So in order to find the total surface area, you will be adding curved surface area plus area of base. Curved surface area plus area of base. What is the curved surface area? Curved surface area is pi r L, and area of base. Area of base. Base is circle. For circle, the area is pi r square, which is equal to pi r into L plus r. So this is the formula to find total surface area. Total surface area is equal to pi r into L plus r. Now, next to find volume. To find the amount or the capacity of this cone. How much ice cream can be filled inside this cone. Inside this cone, not this scoops. Amount of ice cream that can be filled inside this cone. In order to find this, the volume will be helping us. Okay. So volume of a cone, the formula is 1 by 3 pi r square h. Okay. 1 by 3 pi r square h. We have found this pi r square h somewhere. You remember? Volume of a cylinder is equal to pi r square h. So when it comes to the volume of cone, the only difference is you will have to multiply 1 by 3 to this. That is 1 by 3rd of volume of cylinder will give you volume of cone. If you have a cylinder and a cone of equal radius and equal height, then the volume of the cone will be 1 by 3 times the volume of the cylinder. Or the volume of cylinder will be 3 times the volume of cone. You can just remember this. Clear? So now you know how to find the curved surface area, total surface area and volume of a cone. Okay, next is sphere. A sphere is a solid obtained on revolving a circle about any diameter of it. Sphere, spherical shape objects. You know, you have many fruits and vegetables. Then, football, cricket ball, etc. are examples of spherical shape objects. Now, here we have the shape of a sphere. Okay, now how is a sphere obtained? We said that in case of cone, a right triangle. When you take a right triangle and rotate it along the height or the base, you will be getting a cone. Yes, and the base becomes radius. Now, in order to get a sphere, what you do is you take a circle. Okay, circle will be having many diameters. You know, consider any one diameter of the circle, and along this diameter, you make a revolution. You rotate the paper along this diameter. Then what happens when you rotate it? You will be getting a shape. When the speed of rotation is increased, you will find a spherical shaped object. Okay, you can rotate it along any of its diameter. This is one diameter, or along this diameter, along this diameter, or along this diameter. Any of its diameter, when you hold it and make a rotation of the paper, then you will be getting a spherical shape. Clear? Now this circle will be having a radius. Yes, this is the radius of circle, R. The radius of the circle will be the radius of sphere, which is formed in this manner. Okay, now we'll find the surface area and volume. What are the formulas to find surface area and volume of a sphere? Here in case of sphere, you don't have curved surface area and total surface area separately. You just call it surface area. Okay, surface area. Why? Because you don't have an extra base here. In case of cylinder, you had base and top. To the curved surface area, you added the area of base and area of top to get the total surface area. When it was with the case of cone, you had a base. So the curved surface area plus the area of base gave us total surface area. Here we don't have any base in case of sphere. It is only a curved surface. So in order to get the surface area, the formula is surface area of sphere is equal to 4 pi r square. Okay, where r is the radius of sphere. Okay. Next is volume. How to find the volume? In order to find volume, the formula V is equal to 4 by 3 pi r cube. 4 by 3 pi r cube is the formula to find the volume of a sphere. Okay, for example, you all remember the ice creams that were available in the ice cream, which were available in bowl. We call it bowl ice creams. So in this bowl ice cream, what is the amount of ice cream that can be filled? Not the cone ice cream. Here, amount of ice cream that can be filled inside a bowl ice cream. The capacity of this ice cream bowl can be determined with this formula. If you know the radius of this circle, the radius of this sphere, you can easily find what the capacity is using this formula. Understood? So this is a case with a sphere. Next, a spherical shell. So a spherical shell is a solid enclosed between two concentric spheres. So here you will be having an external sphere or outer sphere and an inner sphere. Okay. So you have an outer sphere and an inner sphere. The space inside this inner sphere will be empty. If you need to find the volume of this spherical shell, we need to find the capacity, the amount that can be filled in the space between these two spheres. Okay, that is the space between the inner sphere and outer sphere. Okay, so we have volume of sphere V is equal to 4 by 3 pi r cube. Okay, now what is the volume of spherical shell? What is the volume of spherical shell? How will obtain this? Here, the volume of spherical shell, we have to find the volume of the outer sphere minus the volume of inner sphere. Okay, volume of outer sphere minus volume of inner sphere. Let us take the radius of the inner sphere as small r and the radius of outer sphere as capital R. Okay. Then what is the volume of outer sphere? Will be equal to 4 by 3 pi capital R cube. And the volume of inner sphere will be equal to 4 by 3 pi small r cube. 4 by 3 pi is common. Taking out 4 by 3 pi, we have capital R cube minus small r cube. So the required volume of a spherical shell is 4 by 3 pi capital R cube minus small r cube. If you know the radius of outer sphere and inner sphere, we can find the volume of a spherical shell. Okay, remember here, if you are filling inside this portion, that is, you can never fill, when it is the case of a spherical shell, you can never fill in the space inside the smaller sphere. So this is the region. So this is the required region. I am shading. This is the region. The capacity and volume is determined for this region. Okay. So that is the case with the spherical shell. So the next one is hemisphere. Hemisphere. When a solid sphere is cut through its center into two equal pieces, each piece is a hemisphere. Okay. Here we have a sphere. Through the diameter of the circle of the sphere, if you are cutting, or that is equal halves we are dividing, we will be getting two hemisphere. Now when you consider this hemisphere has a curved surface and a base. Yes, both these hemispheres you can find when you cut along the center. When the sphere is cut along the center, you will be getting hemispheres. These hemispheres will be having curved surface as well as the base. So here in this case, you will have separate curved surface area and total surface area. For a sphere, we only found the surface area. There is no total surface area or curved surface area separately. We only have surface area. But when it comes to the case of a hemisphere, you will be having curved surface area and total surface area separately. So, first let us find the curved surface area of a hemisphere. So how do we get this curved surface? The curved surface is obtained when the sphere is cut into two equal halves. So the surface area of a sphere we know. So half the surface area of sphere gives us the curved surface area of hemisphere. Okay. So sphere area divided by 2, you will be getting the curved surface area of hemisphere. Remember, it is the curved surface area and not the total surface area. Total surface area will be obtained only when the base area is added to this. So, what was the area of sphere? Surface area of sphere is 4 pi r square, where r is the radius of sphere, divided by 2. That is equal to 2 pi r square. Therefore, curved surface area of a hemisphere is equal to 2 pi r square. Next, let's find the total surface area. To find total surface area, as we have done in case of cylinder and in case of cone, you will be having a base area separately. Curved surface area plus base area. Curved surface area is 2 pi r square. Base is a circle and the area of circle we know pi r square. 2 pi r square plus pi r square, we get 3 pi r square. Total surface area is equal to 3 pi r square. Okay, we got the total surface area of hemisphere. Next, to find the volume. Volume again. So how much can the sphere hold? We know the volume of a sphere is 4 by 3 pi r cube. When the sphere is cut to two equal halves, each half can hold a volume that is equal to half the volume of the sphere. Half the volume that the sphere can hold. Yes, which means the volume of hemisphere will be equal to volume of sphere divided by 2. That is 4 by 3 pi r cube divided by 2. 2, 4 cancel, we get 2 here. 2 by 3 pi r cube. Therefore, the volume of hemisphere V is equal to 2 by 3 pi r cube. We know how to find the curved surface area, base area, total surface area and volume of a hemisphere. Is it clear? Here we have all the importance formula that will help us solve problems today. The best thing that you can do is you can copy this formula in a white sheet of paper and stick it somewhere on your wall so that you can just look at it and daily memorize so that you will never forget these formulas. Okay, for a cone, the curved surface area is pi RL and the total surface area is pi r into r plus L. What is L? L is the slant height. L square, we have L square is equal to h square plus r square, where h is the height of cone and r is the radius of cone. Then the volume of cone is equal to 1 by 3 pi r square h. Next, sphere. For a sphere, curved surface area or total surface area you don't have, you only have the surface area and that is 4 pi r square and the volume is 4 by 3 pi r cube. Next, for a hemisphere, the curved surface area is 2 pi r square. Adding a pi r square, you will be getting total surface area which is 3 pi r square and the volume of hemisphere is 2 by 3 pi r cube. You also studied one more case which is the volume of spherical shell. What was the volume of spherical shell? Volume of spherical shell is equal to 4 by 3 pi capital R cube minus small r cube, where capital R is the radius of outer sphere and small r is the radius of inner sphere. If you have all these formulas ready with you, you can easily solve the problems. Okay, let's take some examples and solve. Let us take an example. The radius of the base and the height of a right circular cone are 7 cm and 24 cm respectively. Find the volume and the total surface area of the cone. So here we have a cone. What are the given quantities? The radius of base is given 7 cm. This is radius 7 cm and height is given 24 cm. So first part we have to find volume. Okay, given radius r is equal to 7 cm and height h is equal to 24 cm. What is volume of cone? We have just studied the formula to find volume of cone. V is equal to 1 by 3 pi r square h. Okay, put the values 1 by 3 into 22 divided by 7 into r square. 7 into 7 into h is 24. 7 can be cancelled. 3, 24. 8 we get. So 22 into 7 into 8. When you multiply, you will be getting 1232 centimeter cube. Never forget to put the unit. Okay, so we got the volume. Next, we need to find the total surface area. How to find TSA of a cone? TSA is equal to pi RL, which is the curved surface area plus area of base, pi r square. That is pi r into L plus r. Now we need the value of L. Here we know radius and height, but we don't know what L is. So when you consider this as a right triangle, we have the height 24 cm and base 7 cm. So using Pythagoras theorem, you can find the slant height L. L square is equal to r square plus h square. Put the values. L square is equal to 24 square plus 7 square. Okay. 24 square. 24 into 24. 4 4s are 16. 4 2s are 8, 9. 4 2s are 8. 2 2s are 4. So that is 6, 7 and 5. 576. 576 plus 7 square, 49. When you add, you will be getting 625. L square is equal to 625 and L will be root of 625. Root of 625 is 25. So we got the slant height 25 centimeters. Slant height is 25 centimeter. Now we can find the total surface area. Total surface area is equal to pi r into L plus r. 22 divided by 7. Then r is equal to 7 into L plus r. That is 25 plus 7. 7 gets cancelled. Then we have 22 into 25 plus 7, which is 32. When you multiply 22 into 32, we get 704 centimeters square. If we are asked to find the curved surface area, then only this part is required. Pi RL. Pi RL is the curved surface area. Adding the base area to curved surface area, we get the total surface area of cone. So in this question, we are asked to find the volume and the total surface area. To find volume, we need only the normal height. To find the total surface area or curved surface area, you will need the slant height, not the original height. You will have to find slant height. So never forget to find the slant height and just put the height value here. You will be getting different answer. Okay. Clear? Next example, that is related to sphere. Okay. If the surface area of a sphere is 616 centimeters square, find its volume. So here it is not directly given the radius to find volume. Surface area is given, from which we have to determine the radius first, after which we can find the volume. Surface area is equal to 616 centimeters square. Okay. Surface area 616 centimeters square. What is surface area of a sphere? 4 pi r square is equal to 616, from which we can find the radius. Yes, 4 into 22 by 7 into radius square is 616. Radius square is equal to 616 into 7 divided by 4 into 22. Okay. Now 22 is 11 into 2. 616 is 56 into 11. Now 4 and 56 can be cancelled. We get 14. 2 and 14 cancelled. We get 7. 7 into 7, 49. R square is 49. Then what is radius? Radius will be the square root of 49, which is 7 centimeter. We got radius R is equal to 7 centimeter. Now we can easily find what volume is. Volume of sphere. What is the formula to find volume of sphere? V is equal to 4 by 3 pi r cube. 4 by 3 into 22 by 7. R cube is 7 into 7 into 7. Okay. 7 and 7 can be cancelled. Then when you multiply this, you will be getting the final answer. 1437.33 and the unit is centimeter cube. 1437.33 centimeter cube is the required volume of sphere. You can try the calculation. Very simple, right? Here surface area was given. From surface area we determined radius. Using the radius we found the volume of the sphere. Okay, let us take an example that is related to the hemisphere. The internal and external diameters of a hollow hemispherical vessel are 42 cm and 45.5 cm respectively. Find its capacity and also its inner curved surface area. Okay, we have a hollow hemisphere. So this is a hemisphere, and when it is a hollow hemisphere, it will be like this. To find the capacity we need the inner capacity, right? Inner volume we need. Then outer curved surface area, To get the outer curved surface area, we have to take the outer radius. Here diameters are given. Internal diameter and external diameter. So internal radius, what will be the internal radius? Will be equal to internal diameter divided by 2. Here what is the internal diameter? 42 centimeter. 42 centimeter by 2, that is 21 centimeter. Okay. We need to find the capacity. Capacity means the inner volume. Volume of hemisphere. What is the formula? 2 by 3 pi r cube. Put the values. Here what is the radius? R is 21 centimeter. Inner radius. You have to take the inner radius. That is 2 by 3 into 22 by 7 into 21. 21 into 21. When you calculate this, you will be getting the final answer 19,404 centimeter cube. Just try the calculation. So this is how you can find the volume. You should never use the outer radius. Why? Because inner radius. If you are filling some water inside this, you can fill only in this part. You cannot fill outside the part. Okay. So you have to take the inner radius. Next, to find the outer curved surface area. For that, we need the external radius. What will be the external radius? External radius will be equal to external diameter by 2. External diameter is 45.5 centimeter. 45.5 divided by 2, which is 22.75 centimeter. Okay, so we got the external radius. Using the external radius, we can find the outer curved surface area. Outer curved surface area equal to curved surface area of a hemisphere is 2 pi r square. Okay, here we have the radius capital R, outer radius capital R. So you will be having 2 pi capital R square. Not small r square, because in this case small r is the inner radius. 2 pi, 2 into 22 by 7 into r is 22.75 whole square. When you calculate this, you will be getting 3,253.25 centimeter square. Okay, so outer curved surface area is 3,253.25 centimeter square. Okay, clear? Let us now solve problems from exercise 20B. Here we have the first problem, question 1 of exercise 20B. Find the volume of a cone whose slant height is 17 centimeter and radius of base is 8 centimeter. So we have a cone. Okay, this is a cone. Slant height is given. Slant height is 17 centimeter. This is the slant height, right? Height, radius and slant height. What else is given? We have the radius of base, which is 8 centimeter. Here we have 8 centimeter. Given slant height L is equal to, slant height L is equal to 17 centimeter. Then radius R is equal to 8 centimeter. Here we need to find the volume. What is the formula to find volume of a cone? Volume V is equal to 1 by 3 pi r square h. This is the formula to find volume. Okay. We know what radius is, but we don't know h. What is h? H is the height of cone. This length is h. We need to find h. Here we have a right triangle. Okay. For this right triangle, 17 centimeter is the hypotenuse and 8 centimeter is the base. That is, slant height is hypotenuse, radius is base. Then we can find what the height is. Okay. We have slant height square is equal to r square plus h square. R is the radius and h is the height of cone. H square will be equal to L square minus R square. Yes, H square will be L square minus R square. Put the values. H square is equal to L square, 17 square minus R square, 8 square. What is 17 square? 289. 289 minus 8 square is 64. H square is equal to 289 minus 64. H square is equal to 289 minus 64 is 225. Then what is H? H will be the square root of 225. We all know square root of 225 is 15. Therefore, height H is equal to 15 centimeter. Now we can easily find what volume is. V is equal to 1 by 3 pi. Pi value is 22 divided by 7. 1 by 3 pi R square, 8 square, 8 into 8. H is 15. Okay, so this 3 and 15 can be cancelled. 3 5s are 15. Okay, 22 into 8 into 8 into 5 will be getting 7040 divided by 7. Okay, when you divide this, we get 1005.71. What is the unit here? Slant height is in centimeter, radius is in centimeter, height is in centimeter. Therefore, volume will be in centimeter cube. Okay, never forget to put the unit. Unit is very important. It carries a mark. So, understood? We have to put the values in this formula to find volume. Okay, let's move on to the second problem. Question 2 of exercise 20B. The curved surface area of a cone is 12,320 centimeter square. If the radius of its base is 56 centimeter, find its height. We need to find height. What are the given quantities? We have the curved surface area given. Given curved surface area. CSA is equal to 12,320 centimeter square. Okay. Then radius of base is given. Radius of base R is equal to 56 centimeter. We need to find the height. Height of cone. Height H we need to find. Okay. What is the formula to find curved surface area? Curved surface area is equal to pi RL. When you have a cone, so this is your cone, excluding the base part. Okay, we are not taking the area of base. The remaining area, that is this curved area. When you take, we get the curved surface area. Okay, and the curved surface area is determined using the formula. CSA of a cone is pi RL. Okay, so this pi RL is equal to 12,320 in this case. Pi, R value we know, R value is 56. Into L is equal to, what is L? L is the slant height, 12,320. Okay, pi 22 divided by 7. 22 by 7 into 56 into L is equal to 12,320. Then L is equal to 12,320 into 7 divided by 22 into 56. Okay, just taking all the remaining parts excluding L to the right hand side. Here 22. 22 is 2 into 11. So 12,320 will be getting 1120. Okay, 11 into 1120 is 12,320. Now the 7 and 56 can be cancelled. 7 8s are 56. Okay. Then again 2 and 1120 can be cancelled. We will be getting 560. 560 by 8 is 70. 70 centimeter is the slant height. Slant height L is equal to 70 centimeter. Is it the slant height that we need to determine? No, right? We should find the actual height of the cone. This is the actual height. So we have determined this slant height. We need the actual height h. How to find? We have L square is equal to R square plus h square. Okay. Then h square is L square minus R square. L square minus R square. Put the values. L we have determined, which is 70. 70 square minus R square. What is the value of R? R is given in the question, which is 56. 56 square. H square is equal to 70 square. 7 square is 49 and 2 zeros. Minus 56 square. 56 into 56 you will be getting 3136. Okay. Now subtracting, we get h square is equal to okay, 1764. When you take the root of 1764, we get the value of h, and that is equal to 42 centimeter. Okay, square root of 1764 is 42. So the required height is 42 centimeters. Clear? Third problem, question 6 of exercise 20B. The diameters of two cones are equal. Diameters are equal. If their slant height are in the ratio 5:4, find the ratio of their curved surface area. Okay. Given diameters of two cones are equal. If diameters are equal, then radius will also be equal, right? Why? Because we know radius is half of diameter. If diameter is equal to 2, then radius will be 1. If diameter is 4, then radius will be 2. Okay. So the radius of the two cones will be equal. Let radius of cones be equal to some r. We'll be taking it as r centimeter. Okay. What else is given? Slant heights are in the ratio 5:4. Let slant height of first cone L1 is equal to, given the ratio is 5:4. So we can take it as 5x. 5x centimeter is the slant height of first cone. Okay. If slant height of first cone is 5x centimeter, then what is the curved surface area of first cone? Is equal to, curved surface area we know, pi r l. Okay. That is pi r. L here, L is equal to L1. L1 is 5x. Or this can be written as 5 pi r x. Okay. Now, slant height of second cone L2. Ratio 5:4. So this will be 4x centimeter. 4x centimeter. Okay. Then curved surface area of second cone is equal to pi r L2, which is pi r L2 4x or 4 pi r x. Okay. Then we need to find the ratio of their surface areas, curved surface area. CSA of first cone divided by CSA of second cone. This is how we will be taking the ratio. Here we have the CSA of first cone. Here we have the CSA of first cone 5 pi r x, and the CSA of second cone is 4 pi r x. Okay. Pi cancelled, r and r cancel, x and x cancel. What is remaining? we have 5 by 4. Okay, radius we know, radius of both the cones are same, so it can be removed. Therefore, the required ratio is equal to 5:4. Same ratio that was there for the slant height. Clear? Problem number 4. Question 10 of exercise 20B. A solid cone of height 8 cm and base radius 6 cm is melted and recast into identical cones, each of height 2 cm and diameter 1 cm. Find the number of cones formed. We need to find the number of cones that are formed when a solid cone. So this is a solid cone. It is melted, and with that melted material, we are making many other identical cones. That is, smaller cones are made. Okay, we don't know what the number of cones is. So smaller cones are made. We need to find the number of cones formed, which means the total volume of the solid cone will be equal to number of cones into the volume of a smaller cone. Okay, from which we can find the number of cones. So the first we need to find the volume of solid cone. What is given? Given the solid cone of height. Height of solid cone is given. Given height of solid cone, we'll take it as capital H, equal to 8 cm. And base radius is given. Radius capital R is equal to 6 cm. Okay. Then what is the volume? We have volume is equal to 1 by 3 pi R square H. In this case, we have taken radius capital R and height capital H. Okay. Volume is equal to 1 by 3 pi R square H. Put the values 1 by 3 into 22 divided by 7. Or you can keep this pi as it is. It doesn't matter. Into R square. 6 into 6 into 8. Okay. So 3 and 6 can be cancelled. We get 2. 2 into 6 is 12. 12 into 8, 96. Okay. So this can be written as 96 pi. 96 pi centimeter cube. So this is the volume of the solid cone. Now we'll be finding the volume of smaller cones which are formed. Height of smaller cone, we'll take it as H. Okay, which is given 2 centimeter. 2 centimeter. Then radius. Radius small r. Diameter is given. Diameter is 1 centimeter. If diameter is 1 centimeter, 1 by 2 centimeter is the radius, 0.5 centimeter or 1 by 2 centimeter. Then the volume of smaller cone will be equal to 1 by 3 pi r square h. Put the values 1 by 3 into pi into r square. 1 by 2 into 1 by 2. What is h? H is 2 centimeter. 2. This 2 and this 2 can be cancelled. What we have remaining? Pi by 6 centimeter cube. Okay. We have volume of solid cone is equal to number of cones into volume of smaller cones. Okay. Then what is n? N, number of cones. N will be equal to volume of solid cone divided by volume of smaller cone. Okay. What is the volume of solid cone? Volume of solid cone is equal to 96 pi. 96 pi divided by volume of smaller cone, pi by 6. Okay. Taking the reciprocal and multiplying, we get 96 pi into 6 divided by pi. Pi gets cancelled. Then what we have? We'll be getting 576. N is equal to 576. 96 into 6 is 576. Therefore, the number of cones that can be made when a solid cone is melted in this case is 576 cones. Clear? Problem number 5. Question 14 of exercise 20B. The volume of a conical tent is 1232 meter cube and the area of the base floor is 154 meter square. Calculate the first one, radius of floor, second, height of the tent, and the third, length of canvas required to cover this conical tent if its width is 2 meter. What are the given quantities? We have the volume given. Volume V is equal to 1232 meter cube. Then area of base is given. Area of base. Base is equal to 154 meter square. First, we need to calculate radius. How to calculate radius? Here, area of base is given. Base of a cone. Here we have a cone. Base of a cone we know is circular in shape. Therefore, area of base will be having pi r square. Pi r square value is equal to 154. Okay. Pi 22 divided by 7 into r square is equal to 154. R square is equal to 154 into 7 divided by 22. Okay. 11 into 2 is 22. 11 into 14 is 154. Again 2, 14 can be cancelled. We get 7. 7 into 7, 49. Then what is the radius? Radius will be equal to root of 49, which is 7 meter. We got the radius r is equal to 7 meter. Radius r is equal to 7 meter. Now the second part, we need to find height of tent. How to find height of tent? What is given? Volume is given. What is the volume of a cone? Volume of cone 1 by 3 pi r square h. Okay. We know the value of 1 by 3 pi r square h, which is equal to 1232. From this we can find h. Yes, we can find h. How? We have found the value of r. Either in place of pi r square, we can put the value 154 or r, substitute the value of r. So by substituting the value of r, the cancelling process will be easy. Here 1 by 3 into 22 by 7 into r square, 7 into 7 into height is equal to 1232. 7 gets cancelled. Then height h is equal to 1232 into 3 divided by 22 into 7. Okay. 7 and 1232 can be cancelled. We will be getting 176. Okay. Again, 22 is 11 into 2. 176 is 16 into 11. 2 and 16 cancelled. We get 8. 8 into 3, 24 meter. So the height, required height, h is equal to 24 meter. Clear? We got the radius 7 meter and height 24 meters. Now the third part, we need to find the length of canvas required to cover this conical tent if its width is 2 meter. So let us take, this is a canvas. Width is given 2 meter. We need to find the length. Okay. Now this canvas is used to make the conical tent, which means we need its curved surface area. How to find the curved surface area? Curved surface area of a conical tent will be equal to the area of this rectangle. Okay, curved surface area of this conical tent will be equal to the area of rectangle, because you don't want the base in case of a conical tent. Do we need the base? No, right? So we just need the curved surface area. Curved surface area of a cone is pi r L. Okay, L is the slant height. Now how to find L? Here we have L. This is height and this is radius. Then using Pythagoras theorem, we will be having L square is equal to h square plus r square. L is equal to root of h square plus r square, root of 24 square plus 7 square. We used to do this always, right? So this is a Pythagoras triplet, 7, 24, then the answer is 25. Okay, we have used this triplets many times. So 25 meter is the slant height. We got the slant height. Now we can find the curved surface area. Curved surface area will be equal to pi r L, that is 22 divided by 7 into radius 7, length, slant height 25. Cancelling 7 and 7, 25 into 22, that is equal to 550 meter square, equal to 550 meter square. Okay, so this is the curved surface area of conical tent. Now what is area of rectangle? Area of rectangle is equal to length into breadth or width. Here width is given, length into width. We need to find the length L. Let us take length as capital L. L into width 2 meter is equal to 550, which is the curved surface area. Curved surface area of conical tent. Now length L will be equal to 550 divided by 2, that is equal to 275 meters. Okay, 275 meters is the length of the canvas that is required to cover this conical tent. Okay, understood? We'll solve problems related to sphere from exercise 20C. Here we have question 1 of exercise 20C. The surface area of a sphere is 2464 centimeters square. Find its volume. How to find volume of a sphere? What is the formula to find volume of sphere? Volume of sphere V is equal to 4 by 3 pi r cube. What is this r? R is the radius. Do we have radius given in the question? No. What is given? Surface area is given. Surface area is equal to 2464 centimeters square. How to find surface area of a sphere? The formula is 4 pi r square. 4 pi r square is equal to 2464, from which we can find the value of r. Okay, once you get the value of r, we can easily determine what the volume is just by substituting r here. Okay, r square will be equal to 2464 divided by 4 pi. That is 2464 divided by 4. Pi is 22 divided by 7. Taking the reciprocal and multiplying, we get 7 by 22. Now cancelling 4 and 2464 can be cancelled. We will be getting 616. 22 is 2 into 11. 616 is 56 into 11. 2 and 56 can be cancelled. We get 28. 28 into 7. What is 28 into 7? On multiplying, we get 128. 96. So r square is equal to 196. If r square is equal to 196, what is r? R is the square root of 196. 196 is a perfect square number. Therefore, we get 14 centimeter. Root of 196 is 14. Okay. 14 centimeter is the radius. If radius is equal to 14 centimeter, what is volume? V is equal to 4 by 3 pi r cube. Put the values. 4 by 3 into 22 divided by 7 into r cube. 14 into 14 into 14. Okay. When you solve this, you will be getting 11,498.67. What is the unit? Volume. Therefore, centimeter cube. 11,498.67 centimeter cube. Okay. From surface area, we are finding the radius. Using the radius, we are finding the volume of sphere. Clear? Problem number 7. Question 3 of exercise 20C. A spherical ball of lead has been melted and made into identical smaller balls with radius equal to half the radius of the original one. How many such balls can be made? Similar to this, we have done a question from cones. Okay, in case of cone, a larger cone which was melted to form smaller cones. Here we have a spherical ball which is melted to form smaller balls. Okay, we need to find the number of balls. We are having volume of original ball equal to number of balls into volume of smaller balls. Okay. To find the volume of original ball, a spherical ball of lead has been melted and made into identical balls with radius equal to half the radius of the original ball. Here, in any case, do we have the radius given? No values are given. Okay, we'll take let radius of spherical ball equal to r. We don't have any value. We are taking the radius of spherical ball equal to r. If the radius of spherical ball is r, what is its volume? Volume of spherical ball V is equal to 4 by 3 pi r cube. Okay. Now, what is the radius of smaller ball? How is the radius of the original ball and that of smaller ball related? It is given that radius equal to half the radius of original ball, which means r by 2 centimeter. Okay, r by 2 centimeter. What is the volume then? Volume of smaller ball will be equal to 4 by 3 pi r cube. Here, r by 2 cube. In this case, the radius is r by 2, therefore r by 2 cube. What do we get? 4 by 3 pi r cube divided by 2 cube. 2 cube is 8. 4, 8 cancelled. You get 2 here, which means pi r cube divided by 6 is the volume of the smaller ball. Now, we need to find the value of n. Number of balls n will be equal to volume of spherical ball divided by volume of smaller balls. Smaller ball. Which is, here the volume of spherical ball is equal to 4 by 3 pi r cube. Okay. Here we have pi r cube divided by 6. Now taking the reciprocal and multiplying, we get 4 by 3 pi r cube into pi r cube by 6. The reciprocal is 6 by pi r cube. Pi r cube can be cancelled. 3, 6. Can be cancelled. 3 into 2 is equal to 6. 4 into 2, 8. Therefore, number of bowls n is equal to 8. Here, 8 bowls are formed from the spherical bowl which is melted. Understood? Problem 8. Question 5 of exercise 20C. 8 metallic spheres, each of radius 2 mm, are melted and cast into a single sphere. Calculate the radius of the new sphere. Here number of spheres are given. 8 metallic spheres. Number of spheres n is equal to 8. Okay. Then radius of each sphere is given. Radius of each sphere r is equal to 2 millimeters. Okay, 2 millimeters. Now we need to find the radius of the new sphere. We'll convert this 2 millimeters to centimeter. 1 centimeter, we know 1 centimeter is equal to 10 millimeter. Okay, which means 1 millimeter will be 1 by 10 centimeters. Here we have 2 millimeter. 2 millimeter will be equal to 2 into 1 by 10 centimeter, which is 0.2 centimeter or 1 by 5 centimeter. Okay, we can keep in the fraction form. Now, we can find the volume of each sphere. V is equal to, what is the formula? 4 by 3 pi r cube. Okay, that is 4 by 3 into pi into r cube, 1 by 5 cube. Now, we have 8 such spheres. Therefore, volume of 8 spheres equal to 8 into 4 by 3 pi 1 by 5 cube. Okay. The volume of 8 sphere will be equal to the volume of new sphere. Let us take volume of new sphere equal to 4 by 3 pi capital R cube. Here we have taken capital R as the radius of new sphere. Capital R is the radius of new sphere. Okay. So this volume and the volume of smaller 8 spheres will be equal. Okay. 4 by 3 pi capital R cube will be equal to 8 into 4 by 3 pi 1 by 5 whole cube. Okay. From left hand side and right hand side, the common terms can be cancelled. 4 by 3, 4 by 3, then pi, pi. Therefore, R cube will be 8 divided by 5 cube. What is 5 cube? 5 into 5, 25, 25 into 5, 125. R cube is equal to 8 by 125. Then what is the radius R? Cube root of 8 by 125. Cube root of 8 is equal to 2 and cube root of 125 is 5. 2 divided by 5, which is equal to 0.4 centimeter. Radius of new sphere R is equal to 0.4 centimeter. If you convert this into millimeters, what do we get? We have 1 centimeter is 10 millimeter. 0.4 centimeter will be 0.4 into 10 millimeters, that is 4 millimeters. So it is enough to keep in centimeters. Just I have converted because in the question the radius of smaller spheres are given in millimeters. Understood? Problem 9, question 6 of exercise 20C. The volume of one sphere is 27 times that of another sphere. Calculate the ratio of their radii and the ratio of their surface areas. Okay, given volume of one sphere, we have volume of first sphere is equal to 27 into volume of second sphere. Okay, we'll take the radius of first sphere. The radius of first sphere equal to some r1. If the radius of first sphere is r1, then the volume of first sphere will be equal to 4 by 3 pi r1 cube. Okay. Next, radius of second sphere. We'll take it as r2. Then the volume of second sphere will be equal to 4 by 3 pi r2 cube. Okay. So according to the statement, volume of first sphere is equal to 27 into volume of second sphere. We can write 4 by 3 pi r1 cube is equal to 27 into 4 by 3 pi r2 cube. So the first part, we need to find the ratio of their radii. Okay, so here from both these sides 4 by 3 pi can be cancelled. Then this r2 cube taken to the opposite side, we get r1 cube divided by r2 cube equal to 27. The 27 is remaining here. r1 by r2 whole cube is equal to 27 divided by 1. r1 by r2 will be equal to cube root of 27 divided by 1. If r1 by r2 whole cube is equal to 27 by 1, then r1 by r2 will be equal to cube root of 27 divided by 1. Okay. Cube root of 27 is 3 and cube root of 1 is 1. So the required ratio of radii will be equal to 3:1. Okay. Now we need to find the ratio of surface areas. So to find the second part, we'll take surface area of first sphere. What is the formula to find surface area? 4 pi r square. Here for first sphere it is r1 square. And surface area of second sphere will be equal to 4 pi r2 square. Ratio of surface area will be 4 pi r1 square divided by 4 pi r2 square. Okay, 4 pi can be cancelled. Then you will be having r1 square divided by r2 square, which is r1 by r2 whole square. What is r1 by r2? r1 by r2 is equal to 3 by 1. 3 by 1 whole square, which is 3 square 9, 1 square 1. 9 by 1 and the required ratio is 9:1. Okay. Therefore, we can write surface area of first sphere divided by surface area of second sphere. Surface area of first sphere we have taken as S1 and surface area of second sphere as S2. S1 by S2 or S1 is to S2 is equal to 9:1. Clear? So, we have determined the ratio of radii and the ratio of surface areas of the two spheres. Problem number 10. Question 7 of exercise 20C. If the number of square centimeters on the surface of a sphere is equal to the number of cubic centimeters in its volume, what is the diameter of the sphere? We need to find the diameter of sphere. What is given in the question? It is given that the number of square centimeters on the surface, which means the surface area is given. Okay, surface area is equal to the volume of the sphere. Okay, what is the surface area of sphere? surface area of sphere is equal to 4 pi r square. What about the volume? Volume of sphere is equal to 4 by 3 pi r cube. A sphere of radius r we are considering. Okay. From the given question, it is clear that the surface area and volume are equal. If the volume of sphere is equal to surface area of sphere, we can write 4 pi r square is equal to 4 by 3 pi r cube. Okay. Now, r square and r cube we have here. R square can be cancelled from r cube. Then remaining will be having r. 4 gets cancelled. Pi gets cancelled. Then we have r is equal to 3 centimeters. Okay, the unit we are giving centimeters. Radius is 3 centimeters. Next, we need to find the diameter, because in the question we are asked to find the diameter. Diameter is equal to 2 times radius. Here we have determined the radius, and radius is equal to 3 centimeter. 2 into 3 centimeter, that is 6 centimeters. So why I have taken the unit centimeter, why not meters? Because in the question it is given square centimeters. Area is in square centimeters and volume is in cubic centimeters. So the unit should be centimeter. Okay. Even though we don't have any values in the question, the units you have to keep in mind. Here area is in square centimeters and volume is in cubic centimeters. Clear? So we have determined the diameters. Here we have the last problem for today. Problem 11. Question 10 of exercise 20C. A solid sphere and a solid hemisphere have the same total surface area. Find the ratio between their volumes. Okay. So you have a solid sphere and a solid hemisphere. This is a hemisphere and this is a sphere. We have the total surface area of sphere and hemisphere equal. Let us say, let radius of sphere be R1 and radius of hemisphere be R2. We have taken R1 as the radius of sphere and R2 as the radius of hemisphere. Now what is the total surface area of sphere? Total surface area of sphere is equal to 4 pi r square. Here radius of sphere is R1. R1 square. Total surface area of hemisphere. Total surface of area of hemisphere will be equal to the curved surface area plus area of base. Base is a circle. So we will be getting 3 pi R2 square. R2 is the radius of hemisphere. Given that in the question total surface area of the sphere and hemisphere are equal, which means we can write 4 pi R1 square equal to 3 pi R2 square. Okay. From which we can cancel pi. R1 square divided by R2 square is equal to 3 by 4. Okay. Just taking this R1 square to the left hand side and 4 to the right hand side. Then what is R1 by R2? R1 divided by R2 will be equal to the square root of 3 by 4, which is root 3 divided by 2. Root of 4 is 2. Root 3 by 2. R1 by R2 is equal to root 3 divided by 2. Now how to find the volume of sphere? What is the formula? Volume of sphere is equal to 4 by 3 pi r cube. So here R1 cube. What about the volume of hemisphere? What is the formula? Volume of hemisphere is equal to 2 by 3 pi R2 cube. Okay. So we need to find the ratio between the volumes. Volume of sphere divided by volume of hemisphere will be equal to 4 by 3 pi r1 cube divided by 2 by 3 pi r2 cube. Okay, from which we can cancel pi, 3 can be cancelled, 2 and 4 can be cancelled. Here we get 2. So 2 r1 divided by r2 whole cube. What is r1 by r2? r1 by r2 we have determined from the total surface area, which is root 3 divided by 2. Substituting here, we get 2 root 3 divided by 2 whole cube. Root 3 into root 3 into root 3. That is 3 root 3. 3 root 3 into 2 divided by denominator we have 2 cube. 2 into 2 into 2. 2 and 2 can be cancelled. Then what is remaining? 3 root 3 divided by 4. So the ratio is 3 root 3 divided by 4. Okay, 3 root 3 by 4 is the ratio of volume of sphere to the volume of hemisphere. Clear? That's all for today. In today's class, we have discussed how to find the curved surface area, total surface area, and the volume of sphere, hemisphere, and cones. Hope you all enjoyed this session. We have solved many questions from exercise 20C and 20B. There are a few more questions which are remaining, which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.